So how do we get from the research that you're doing and the experiments that you're doing to changing international agriculture? So if we have 10,000 years of doing it one way, we know there's a problem. Do you have a vision for how we move from kind of experimentation and the success of some of these perennials to widespread implementation?
Yeah. What you do is you go to people that have billions of dollars.
It's the answer to everything.
Huh?
That's the answer to everything.
Well, there are a lot of those folks.
Yeah.
There are 1,236 of them in the world. And the printout will give you 30 pages. And 10 and a half of those pages are in the United States. And so you go to the foundation world and say, look, we can build an agriculture as sustainable as the nature we destroy. And we can, in fact, we're now arguing that if you want high yields, you're going to have the perennials. They have a longer photosynthetic period than the annuals generally. So go to the foundation world and say, okay, go ahead and devote your time to the here and now. We got 7 billion going to 9 billion. Then what? Right now, I just read this actually last week, that on a global basis, we're now losing from agriculture 30 million acres a year. That is about 9% of the total U.S. ag acres that's being lost worldwide. So in this effort to feed, these 7 going to 9 billion, the here and now, we're saying what we need is a 30-year research agenda. And Asia, Africa, Latin America, we're calling for the training of 110 PhD level scientists that would work in 11 or 12 different sites around the globe, along with their technicians and support staff, a total of 30 per site. And the total cost over a 30-year period, and stay focused on that 30-year period. Now, work alongside the here and now folk, and there will be leakage both ways, but don't be distracted. Just keep your eye out there. The total cost over a 30-year period at $1.64 billion. Sounds like a lot of money. It happens to be 1/3 the current subsidy this year for ethanol in the United States, which is just nuts anyway.
Yeah.
So, yes, clap.
And when you say losing,
what?
when you say we're losing,
going out of production due to erosion.
Yeah.
I may show you a slide on erosion if you beg me.
Yeah.
So, let's keep going here. I mean, make one word worth 1,000 pictures for a while.
Okay.
Yeah.
So, when you talk about that level of systemic change, you said it's about more than food, right?
It's what?
You said it's about more than food.
Yeah.
In your book, you said
Right.
Agriculture has the sole potential to provide the lead into a different relationship with our ecosphere.
Right.
So for some people, agriculture is the kind of linchpin issue, but for other people, they don't see it that way. So maybe you can help us to understand the sort of fundamental role of food in agriculture.
Yeah. Well, first of all, acknowledge that as long as you got the annuals, you're tearing up the ground every year, or if you have minimum till, no till, you're using herbicide. So the philosophy there is we have to poison the soils to save them. That came out of a war we had. So if you just look at the most important invention of the 20th century, in some respects it tells it all. 1909. 2 Germans, Fritz Haber and Karl Bosch, learned how to take atmospheric nitrogen and turn it into ammonia. It's called the Haber-Bosch process. Without Haber-Bosch, Vaclav Smil, University of Manitoba, who's a good scholar on nitrogen, says that without Haber-Bosch and natural gas as a feedstock, 40% of humanity wouldn't be here now. Now, let's be clear of what the standing crop of Homo sapiens is dependent upon. Natural gas in this case. Of course, then there's all the fossil fuels for the industrial stuff. combines and plows and so on. So if we can, though, look at a natural ecosystem where there are legumes that will biologically fix nitrogen, and one of the species we're working with is Illinois bundleflower, which is a very active nitrogen fixer, has a nutritional profile not too different from soybean. Have that in the mix to take care of some. And it could be we could use wind machines to supply some energy for running Haber-Bosch. It's not a very good way to use electricity, but we could do that. We could begin to think about, with species diversity, you have chemical diversity, so it takes a tremendous enzyme system on the part of an insect or a pathogen to give you the epidemic. So we can begin to think about an agriculture that in which the drawdown of the capital stock can go to zero. Well, think of it this way. You remember your periodic chart in your chemistry classrooms, 100 and some elements. In the upper third are 20-some elements that go into life. There are only 4 of those in the atmospheric commons: carbon, hydrogen, oxygen, nitrogen. The other 20-some are in the soil. So if you can, and by the way, going into an organism, only like 15% of those that are in the soil go into the organism. But if you don't have those for your system, you can't capture your CO2 out of the atmosphere and your water and so on to make your sugars. So we can begin to think seriously about bringing those processes of the wild to the farm now that we have perennials on the horizon. Now think of it this way. Ecology and evolutionary biology as a discipline has been accumulating data for over 100 years. The National Science Foundation in 1980 started funding what they called the LTERs, the long-term ecological research sites. The Konza Prairie is one of them. There are millions and millions of dollars spent to understand how rainforests work, how prairies work, how natural ecosystems work, but that knowledge has been largely non-applicable to agriculture because you've got the annuals and you're tearing the ground up every year. You're clear cutting every year. But now with the perennials on the horizon, we can bring ecology and evolutionary biology with the modern molecular synthesis to inform a research agenda and have those efficiencies that we talk about, and contemporary sunlight pay the bills. This is a conceptual revolution more important than the Copernican revolution. We didn't need it when we got that. I mean, I'm glad we've had it all right. But we've done a lot of terrible things with that Copernican revolution. But the thing is, we didn't need that, but we need this.
And that's really when we were talking earlier about what's different now.
Yeah, well,
we're ready now because of the molecular biology and the what we know now.
Right. We've got, when I published on this, it's in Not Man Apart, I said this is 50 to 100 year program. We didn't have any quick fix. Well, that caused a lot of people not very interested. But all of our major problems have long-term fixes now, whether it's population or global warming. Suddenly, we're in the short period of solution. So, yeah.
All right.
There we are.
And then in there, and I know this is sort of the layperson's question, but why is grain specifically important?
Well, 70% of our calories are from grains, and they grow on 70% of our acreage, 70% of our ag acreage. So, if you look at the sustainable ag movement, our good friends that work in sustainable ag, and see the posters that they will use to advertise the sustainable ag, what do they have? They have vegetables and fruits, health. Poster after poster will leave off the grains. And yet that's 70% of our calories, 70% of our, occupying 70% of our acreage. So when I go from the East Coast to the West Coast, in fact, I have a bet that 70% of the calories that Californians eat come over the Sierra Nevada. And that 70% of the calories that the folks on the East Coast eat come over the Appalachians. Meanwhile, flyover country is where the soil erosion is, where the chemical contamination is really acute. Look, here's the reality. These sustainable ag groups, these are our friends, and these are the folk that are the core for the constituency. But they're donuts. There's a donut around Berkeley. There's a donut around Lawrence. There's the donut around, Washington, D.C. There's a donut around Chicago, donut around St. Louis. There's donuts everywhere. But most of the landscape of the United States is being drenched with fertilizers, pesticides, and the soil's eroding. Well, it's just, we got to start with the reality that soil is more important than oil and as much of a non-renewable resource as oil. And start there. But it's hard to get people's attention. One of these days I'm going to create a doll that's sure to make the Land Institute millions of dollars. I'll call it the American doll. You wind it up, and it loses interest. So, I think it'll sell.
I think so too.